Hi everyone, I'm going to teach you the second learning target for Unit 8, Sequences and Series. The learning target 2 is I can write, that's part 1, and use, that's part 2, equations of arithmetic sequences. Remember, an arithmetic sequence is a sequence that has an adding pattern. Today is the 17th, or whatever date it is, if you're watching this earlier or later than when it's posted on our classroom. Part 1. I'm going to use the same example that we used in our Learning Target 1 notes. Write an arithmetic explicit equation for 2, 5, 8, 11, and so on. So the reason we want to write an explicit equation is to model what's happening, so model the pattern that's happening in the sequence and where that sequence is starting, and be able to use that equation then to find any term, I think we said the 107th term, or any high term that we want in this sequence without continuing the pattern over and over and over again. So in order to write the arithmetic explicit equation, let's figure out what function this is first. So I'm going to plot each of these terms on a graph. Quickly, I said this in the first video, but we're not using x anymore, we're using n, and n just stands for the term number. So because 2 is the first term, the point that I would plot is 1, 2. Because a sub 1, the first term, is 2. A sub 2 over 2 is 5. A sub 3 over 3 is 8. I don't have room on my graph, but a sub 4 is 11, and hopefully you all see now that an arithmetic sequence, when plotted on a graph, is linear. So because this is linear, we can be thinking about the slope-intercept form of a linear equation. Y equals mx plus b, where m is the slope and b is the y-intercept. But instead of using y, we're going to use our sequence notation. So a sub n equals, and let's figure out what our slope of this line is. From the first term, we go up 3 over 1. So 3 is the slope. Instead of x, I'm using n. And then plus b. b is my y-intercept, but I don't see that on the graph because the y-intercept would not be the first term, second term, or third term. The y-intercept would be the 0 term. So I'm going to go backwards, down 3, because the slope was 3, over 1 to figure out my 0 term, which is negative 1. So that's the arithmetic explicit equation for this sequence. Now, do I want to graph every single sequence to figure out the equation? No. So instead, we already know that this last term is the 0 term. What does 3 stand for? Well, we know it's the slope on a graph. But what is it in the sequence? Well, from 2 to 5, 5 to 8, and 8 to 11, the common difference is 3. So the common difference is the slope of the line. So let's write our arithmetic explicit formula that we're going to use in the next 3 examples. The arithmetic explicit formula with no numbers in it would be a sub n equals the common difference times n plus a sub 0. And we can be thinking of y equals mx plus b. Now, what if I didn't have the 0 term? So there's different forms of this arithmetic explicit formula that we can use that I think will make it easier for the other examples. If we have the first term, so a sub 1, then think of that first term on the graph, shift it over to the right one. all we need to do in our equation is shift over to the right one, which remember transformations, shifting to the right one is -1. And I can use this if I have any term. Let's say I have a sub 2, the second term of the sequence. Then I'll shift over to the right 2. If I have the third term, shift over to the right 3, and then add the third term. Any term I want, I can use the 200th term, so shift it to the right 200 plus a sub 200. All of these forms will all simplify after I distribute and combine like terms. They'll all simplify to that original arithmetic explicit formula. Now, because sequences usually start with the first term, if you were to Google arithmetic explicit formula, you'd most likely see this form that uses the first term, because sequences start with the first term. But all of these, again, are all forms of the exact same arithmetic explicit formula. So write this down, super important, put 5 stars around it, 10 stars around it, whatever you have to do. Arithmetic explicit formula. Now let's use it. I have 3 examples of how you're going to use the arithmetic explicit formula. Example 1. Write the simplified explicit formula given a sub 3 is 10 and the common difference is -2. So my arithmetic explicit formula starts with a sub n equals the common difference, and they gave me the third term, so I'm shifting to the right 3, and then I'll add the third term. A sub n equals, the common difference was -2, times n minus 3, I shifted to the right 3 because they gave me the third term, plus, and they gave me the third term was 10. Now all I have to do is simplify. So I'll distribute the -2. A sub n equals -2n plus 6. Careful, negative times a negative is a positive. Plus 10. Combine like terms. A sub n equals -2n plus 16. And there's my simplified explicit formula. Example 2. Write the simplified explicit formula given the sequence 1/2, 1.5, 2, 2.5, 3. So start with a sub n equals the common difference times, and now I have the first, second, third, fourth, and fifth terms. I can use any one that I want. I'm going to use the first term, n minus 1 plus a sub 1. A sub n equals the common difference. They didn't tell me what it was, but I can see that I am adding, oh geez, this is wrong. I'm adding 1 here, and then I'm adding half, half, half. So let's change this. Let's make the first term be 1. There we go. So I'm adding a half every time. The common difference is 1/2 times n minus 1 plus, what was the first term? Well, we have the correct first term now is 1. I'll just distribute, combine like terms, so I'm distributing 1/2. A sub n equals 1/2 n minus 1/2 times -1 is 1/2 plus 1. Combine like terms, a sub n equals 1/2 n, and then -1/2 plus 1 is positive 1/2. There's your arithmetic explicit formula. Last example in part 1. Write the simplified explicit formula given the arithmetic sequence terms a sub 5 equals 8. So the fifth term is 8, and a sub 17 is 56. So here we go. A sub n equals d times I can use either the 5th term or the 17th term. I'm going to use the 5th term. So I'm shifting to the right 5, and then plus a sub 5. I don't know the common difference, but think back to the graph. The common difference is slope. So I'll just find the slope between our 2 points, which is y2 minus y1 over x2 minus x1. So 56 minus 8 over 17 minus 5 is 48 over 12, which simplifies to 4. So for my equation then, 4 is the common difference, times n minus 5, because I'm using the 5th term, plus 8, which is the 5th term. Distribute the 4, and I get a sub n equals 4n minus 20, plus 8. Combine like terms. And my simplified explicit formula is a sub n equals 4n minus 12. So that's how you write arithmetic explicit formulas. Part 2. Use arithmetic explicit formulas to find any term that I want. So here's the example that we had from Learning Target 1 notes video. Find a sub 107 given this sequence. Common difference is 3, plus 3 each time. So I need an explicit formula to then plug in 107 to. A sub n equals common difference times, I'll use the first term. Oops, that should be an n. Using the first term, so I shift to the right 1. And then the first term was 2. Distribute 3n minus 3 plus 2. Combine like terms. 3n, negative 3 plus 2 is negative 1. So now I use this formula. Sorry, Noah's crying. I use this formula to find the 107th term. Notice 107 is replacing n. So all you need to do is plug in 107 in for n. And then simplify that. So 107 minus 1, 107 times 3 minus 1 is 320. So the 107th term is 320. Last example to use the arithmetic explicit formula is in a table. So find a sub 300, the 300th term, given the sequence in the table below. The table is giving us the 10th, 11th, 12th, and 13th terms. And here are those terms, 2, 7, 12, 17. So I have to write my explicit formula first. A sub n equals d. Let's figure out what that is. From 2 to 7, we add 5. So 5 times n minus, I'll use the 10th term. You can use any term you want. I'm going to use the 10th. So I shift to the right 10. The 10th term is 2. Distribute the 5. A sub n equals 5n minus 50 plus 2. So a sub n equals 5n minus 48. And then I'll use this arithmetic explicit formula to find the 300th term. So notice 300 is replacing n. All I have to do is input 300 in for n in the equation and simplify. 5 times 300 is 1500, minus 48 is 1452, which is your 300th term. So if you have any questions, concerns, let me know. Send me a remind, send me an email. I really miss you guys. I care about you. I hope you're all doing well. Bye.